In this next video, I'm going to go over the next set of problems involving solving equations. And the first thing I'm going to do is jump back up here to number 3. This is a solving equations problem. It's kind of out of order. So when we're solving, what we're trying to do is identify what the value of the variable should be to make the statement true. And so how we solve this is we use two ideas: inverse operations, which is the idea that addition and subtraction undo each other, and multiplication and division undo each other. So we're going to be using that idea, and we're also going to be using the golden rule of algebra, which means whatever you do to one side, you must do to the other side, and we're going to show that work. So in order to get x by itself, the first thing I'm going to do is add 15 to both sides. That's going to get rid of it here. Negative 15 plus 15 cancels, giving me 0. So I'm left with negative 8x equals, and then negative 31 plus 15 is a negative 16. The last thing I need to do is divide both sides by negative 8. Negative 8 divided by negative 8 is 1, leaving me with just x. And negative 16 divided by negative 8 is a positive 2. So my answer here is 2, which is C. Now I'm going to go back down to number 12. Here I also have a variable x that I'm trying to get by itself. I'm trying to solve for x. This one's different though because I have x's on both sides. So the first thing that I want to do is get those x's together on the same side. So I'm going to subtract 4x from both sides. On the right-hand side, 4x minus 4x cancels, which is what I wanted. On the left-hand side, 8x minus 4x is 4x, and everything else will drop down. Minus 5 equals 23. To get this 4x by itself, I'm going to do the opposite of minus 5, so I'm going to add 5 to both sides. Negative 5 plus 5 cancels, giving me 0, and leaving me with 4x, which is equal to 28. In order to get the x completely by itself, I'm going to undo 4 times x by dividing both sides by 4. 4 divided by 4 is 1, leaving me with x equals 7. The correct answer here is B. For this next one, the variable I'm solving for is y. In order to get the y by itself, I just need to move this negative 18. I'm going to add 18 to both sides. Negative 18 plus 18 cancels, which is what I wanted, leaving me with y equals negative 3 plus 18 is 15. On number 14, my variable that I'm solving for is n. I have 5 times n equals 35. So to get rid of that 5, I'm going to divide both sides by 5. 5 divided by 5 is 1, leaving me with n equals 7. B. On number 15, I have 3/5 x equals 15. My variable here is x. I'm multiplying 3/5 times x. So in order to undo this, we actually multiply by the reciprocal, which is the flip-flop. When I multiply by the reciprocal, the 5 cancels with 5, 3 in the bottom cancels with 3 on top, leaving me with x. And then whatever I do on the left, I have to also do on the right. So I'm going to multiply by 5 over 3. In order to solve this, 15 times 5 is 75. Divide by 3 is 25. So x equals 25. C. Looking at number 16, the variable I want to solve for is t. So the first thing I want to do is subtract 1 from both sides. 1 minus 1 cancels, giving me 0. So I'm left with 2t equals 2. To get the t by itself, this is 2 times t. I'm going to divide both sides by 2. 2 divided by 2 is 1, leaving me with t equals 1, which is A. In the next example, our variable is also t, except I have t on both sides of the equation. So the first thing I want to do is get the t's together. I'll go ahead and move this t over by subtracting t from both sides. T minus t cancels. On this side, 3t minus 1t is 2t minus 6 equals negative 2. Be careful that you're dropping those negatives down. In order to get the 2t by itself, I'm going to add 6 to both sides. Negative 6 plus 6 is 0, leaving me with 2t equals 4. And finally, I'm going to divide both sides by 2. 2 divided by 2 is 1, leaving me with t equals 2. C. In the next example, my variable is also t. I have a t on the left and a t on the right. On the left-hand side, though, my t is inside parentheses. So the first thing I need to do is distribute the 4 throughout. 4 times t is 4t. 4 times 1 is a positive 4 equals 6t minus 1. Now I want to get the t's together on the same side. I'll go ahead and subtract 4t from both sides. 4t minus 4t is 0, leaving me with 4 equals 2t minus 1. To get 2t by itself, I'm going to add 1 to both sides. On the right, the 1's cancel. On the left, 4 plus 1 is 5 equals 2t. To get the t by itself, I'm going to divide both sides by 2. So I'm left with 5 halves, t equals 5 halves, but that's not an option. The options are written as mixed numbers, so this can also be written as 2 and 1 half, which is A. On number 19, I'm also solving an equation. My variable this time is g, and I have 3 g's. I also will need to distribute. On the left, I have 5 times g and 5 times negative 2. This will just drop down. And on the right, I have 6 times g and 6 times negative 4. So 5 times g is 5g. 5 times negative 2 is negative 10. The plus g drops down. This is equal to 6 times g, which is 6g, and 6 times negative 4, which is negative 24. Next, I want to try and get all my g's together, but I first want to recognize that on the left-hand side, I can actually simplify. I have 5g plus g. Since these are on the same side, I'm not going to use inverse operations. I'm just going to put them together. So 5g plus g, that's like a 1g, is 6g minus 10 equals 6g minus 24. So the next thing that you might try to do is get your g's together. So I'd subtract 6g from both sides. Well, what happens here, 6g minus 6g is 0, and 6g minus 6g is 0. So all I'm left with is negative 10 equals negative 24. This is not, it doesn't mean necessarily that you made a mistake. What this means is this true? Negative 10 equals 24. Is that true? No, these are not equal. It's false. So what that means is there's no solution here. This symbol right here means no solution. So if you work it out and you get to the point where your variable cancels out and you're left with a false statement, that means no solution. Now we'll take a look at number 20. It's asking us to find the correct value for x. The first thing that I need to do is distribute. On the left, I'm distributing 2/3. I'm going to pass it out to the 6x and to the 30. And then on this side, this x is just going to drop down on its own. I'm going to pass out the 5 to the parentheses, and then this negative 2x is just going to drop down as well. When we're multiplying fractions, we multiply the numerator times the constant, so times the coefficient. 2 times 6 is 12, and then I divide by whatever's on bottom. So 2 times 6 is 12, divided by 3 is 4. You could also plug that in your calculator, 2/3 times 6, and you get 4. And I keep the x. Again, I'm going to do 30 times 2, which is 60. 60 divided by 3 is a positive 20. Equals, drop down my x, plus 5 times x is 5x. 5 times 4 is a positive 20. And then I'm going to drop down this negative 2x. So I first want to do some simplifying here before I start to solve. Again, I have a lot of x's. I've got 4x on the left, and on the right I have x plus 5x minus 2x. So before I start moving anything to the other side, I'm going to simplify what I have already. On this side I have 1x plus 5x, which is 6x, minus 2x, which is 4x. So I can just combine those since they're on the same side. The plus 20 drops down, and on this side I have 4x plus 20. Now at this point you might recognize we have 4x plus 20 equals 4x plus 20. What's going to happen, just like in our last example, is if I subtract 4x to try and get these together, these are both going to cancel, leaving me with 20 equals 20. Well, unlike our last statement, we can ask ourselves, since our x is canceled, is this true? And the answer is yes, this is true. So instead of having no solution, we actually have infinite solutions, or all numbers. That means you could plug any number in for x, and it would work.